Hello and welcome. My name is Elhelw. We've talked about database design in the previous video, and one of the topics that we talked about was the ER diagram or the entity relationship diagram, which is a tool that you can use to represent your data in terms of entities, attributes, and relationships. I got a bunch of questions about the relationships aspect of an ER diagram, and some folks wanted more information about that, so this is what we are going to talk about today. But before we get into that, I want to do a quick recap about entities and attributes. I will also put a link in the description for the previous video, and I'll also put it up on the screen here, so feel free to take a look at it if you haven't seen it yet. So starting with entities. Entities, as we mentioned, are any kind of thing that you want to represent in your database. This could be something physical, like a student or a car or a product or a person, or it could also be something non-physical or more conceptual, like account or course or shopping order. So things that are not really physical. But all of these can be considered as entities in your database. Each entity has some attributes. Attributes are the details or the information associated with that entity. For example, if we're talking about the customer entity, some of the attributes might be name, email, phone number, shipping address, and so on and so forth. So this is the information that is relevant to your application, and this is the information that you want to represent in your database. Of course, there will be lots of other information about each entity, but you only want the relevant things to store. How do we represent these in an ER diagram? Usually in this format, entities are represented as a rectangle, attributes are represented in this oval shape, and they're connected to the entities that they are associated with. Just a quick note on the side, there are many different ways to represent entities and attributes in ER diagrams, different notations. We're going to be using this notation for the majority of the video, and then I will show another notation at the end. But this is kind of like a recap of entities and attributes and what they mean and how they are represented. Next, we're going to talk about the main topic for today, which is relationships. What are relationships? Relationships are connections or links between entities. Entities do not exist in a vacuum. They don't exist by themselves. There are ways to connect these entities together. So, for example, if we are talking about a company database, we may have something like this: employee works in company. This phrase has two entities, which is employee and company, and it has a connection between them, which is works in. In our case, that is a relationship. This is how we represent how these two entity types are connected together. Another example, if we're talking about a school database, so you have students and courses, and then you have a relationship that connects them together that says which student studies or which student is enrolled in which course. So again, you connect these things together. How do we represent that in an ER diagram? This is the format that we're using. Usually the relationship is represented in this diamond shape, and it connects to the entities that it links. So here we have the employee entity with its attributes, we have the company entity with its attributes, and then we have the works in relationship in between. Relationships have a lot of different properties that we're going to talk about today. The first property is something that we call the degree of a relationship. The degree of a relationship tells you the number of entity types that this relationship connects. What does that mean? Usually what we have seen so far is that a relationship connects two things: student and course, or employee and department, or something like that. That's not always the case. You can connect more than two, you can connect less than two. This will become clear as we start giving some examples here. So let me start with the basic case. The basic case is degree equals to 1. What does that mean to say degree equals to 1? We call that a unary relationship. How can a relationship connect one thing? Connected to what? When we're talking about connecting entity types, we're talking about the type, not the instances. For example, if we're talking about students, student is an entity type. John, Anna, Alice, Robert, these are instances of that entity type. So when we say a unary relationship, it connects an entity type to itself. Suppose that you have, you're doing a database for a social media platform like Facebook or Instagram or something. In that platform, you have users. So you have a user entity. There might be millions of users, but they all belong to the same entity type. You have a relationship called, friends. A user can be friends with other users. So the two things that are connected by this relationship are of the same entity type. So you have a relationship called friend with, it connects two things of the same entity type. So this is a unary relationship. It might be connecting different instances of user, but it's still the same type. So this is what we mean by a unary relationship. It connects a single entity type. If degree equals to 2, we call it a binary relationship. This is what we usually see in most of the examples. So we have two different entity types and then a relationship connecting both of them together. In this case, employee works in company. Just a quick note, I am not displaying the attributes anymore. I'm just focusing on the entities and the relationships. But implicitly, we know that employee has attributes and company has attributes. So this is a binary relationship, means degree equals 2. You have two different entity types. You could go higher, so degree equals 3. This is what we call a ternary relationship. Now this means that we connect 3 different entity types. What's an example of that? If we have teacher, course, and student, and you want a relationship that captures that, saying that this teacher teaches this course to this student. So you have a relationship that connects all 3 entities. So again, the degree is the number of entity types that are connected by a given relationship. We've seen unary, binary, and ternary. Can we have more than that? Yes, you can have any number of entities connected by a relationship. So the degree can be more than 3. However, most of the common cases are either, between 1 and 3. It's very rare to find relationships that connect more than that. Another thing that I wanted to mention, it's not really related to the degree, but just kind of like a side note. Between the same entities, you might find actually multiple relationships. Like it's not necessarily just one relationship connecting any given number of entities. What does that mean? If we look at the employee and department entities, right? We said that you might have a works in relationship. So employee works in department. You might have additional relationships that still connect the same entity types. For example, you might have a second relationship that says manages. So employee manages department. So the employee can be a manager and manage a department, but also you have employees working in a department. So you have 2 different ways to connect these 2 entity types. So just wanted to note that in case you see it anywhere. No, it can happen because each relationship has different meaning. So this is very possible, and you'll find that in many databases. All right, so we've talked about the degree of a relationship. Another properties of relationships are 2 things called cardinality ratio and participation. Those 2 pieces of information, they let us know more about the entities that are connected by that relationship and how they take part into that relationship. That I know it doesn't make sense yet, so we're going to explain that with examples. Let's talk first about the cardinality ratio. Cardinality ratio, the definition is the maximum number of entity instances connected by a relationship. I know it doesn't make a lot of sense, but let me explain it this way. If you're talking about a relationship that connects a bunch of entities, right? Each of those entity types, like I said, it has many instances. Like if we're talking about a student, you have many actual students within that entity type. Each of those students, how many objects on the other side of the relationship do they connect with? Basically, we want to know it's either one or many. Like each object can connect to only one other object maximum, or it could connect to multiple other objects maximum. So this is what the cardinality ratio tells us. So it's either one or many for each side of the relationship. So if you're talking about a binary relationship, you have 2 sides, right? Each side can be either one or many, so you have 4 different combinations. You might have a one-to-one relationship, you might have a one-to-many, many-to-one, or many-to-many. If we're talking about a ternary relationship, so a relationship of degree 3, so you have 3 different entities, each of them can be one or many, so then you have many more options. You have like one-to-one-to-one, one-to-many-to-one, one-to-one-to-many, and so on. So just keep that in mind. So this is basically trying to figure out how many objects maximum we can connect to on the other side. Let's see some examples. Let's talk about the employee manages department relationship. I know it's written up there that's one-to-one relationship, but how do we know that? So to know that, we ask this question. Let's start from the employee side. From the employee to the department. For each employee, how many departments does an employee manage? An employee can manage a maximum of one department. At least let's say that this is the case for our example here. So the maximum is one department, so we'll say, okay, so we're just going to put one on this side. We ask the same question from the other side. So a department, how many managers does it have? Again, the maximum number. In most cases, a department can only have one manager, assuming that's like the head of the department. So maximum also one. So this is why this is called a one-to-one relationship. Let's see another example. Let's talk about employee and department, but now the relationship is not manages, the relationship is works in. So asking the same questions. From the employee side, how many departments does this employee work in? Employee usually works in just a single department, so the maximum is one. But from the department side, how many employees work in that department? Usually many, so the maximum is n. So this is a many-to-one relationship, or one-to-many relationship, depending on how you look at it. Let's see another example. Order and product. Suppose we're talking about a shopping website, or like e-commerce like Amazon or something like that. So you have orders and you have products. Starting from the order side, how many products are in one order? An order can have many products, right? Not just one. So the maximum here is n. Going from the other side, for each product, how many orders contain that product? Product can also be in multiple orders. So this is a many-to-many relationship. And we use m and n, not n on both sides, to indicate that these are not necessarily like the same number. So this is what cardinality tells us. Each entity on one side, how many other objects on the other side can it connect with? What about participation, the second property that we talked about? Participation describes how an entity participates in the relationship. It also doesn't make a lot of sense, so let's break it down. Each entity instance, again, if we're talking about the employee and departments, does each employee have to be part of the relationship or not? So the two possibilities here are either total participation or partial participation. Another way to ask the question is, does every entity instance have to participate, like I said? So it's either optional or mandatory. If it's optional, then this is a partial participation. If it's mandatory, then this is a total participation. What does that mean in practice? Let's illustrate that with an example. Here we have the employee manages department, and we agree that this is a one-to-one relationship. Now let's look at the participation. Let's ask on the employee side. Does every employee have to participate in this relationship? What does that mean? Like, does every employee have to manage a department? No. Some employees are not managers. Some employees are. So this is optional on this side, which means this is a partial participation. So partial participation is represented by a single line, as we already have it here. Now let's look at the other side, on the department. Does every department have to be part of this relationship? What does that mean? In the context of the managers relationship, does every department have to have someone managing it? Yes. So it's not optional, it's mandatory. So this is why it's a total participation. And total participation is represented by two lines, not a single line. So we change that to reflect the total participation in this case. Let's see another example. Now we have the orders and products example. And this is a many-to-many relationship, as we've already seen. So let's start from the order side. Does every order have to participate in this relationship? What does that mean? Does every order need to contain products? Could there be an order that does not contain any products? No, that doesn't make sense. Like, it doesn't make sense to have an empty order. So each order must contain products. So this is a total participation. So total participation is double lines. On the other side, the product. Does every product have to be part in this relationship? What does that mean? Does every product have to exist in some order? No. Some product you might just have been added to the database and no one has ordered it yet. So it exists in the database, but it doesn't exist in any orders. So this is a partial participation on the product side. So this is a single line in the diagram. So this shows what the participation means. So now we can look at cardinality and participation together. You can actually kind of like think of them as something analogous to each other. How so? Cardinality tells us about the maximum number of objects that a given object connects to. It's either one or many. Participation tells us about the minimum number of objects that it connects to. So optional means that it connects to 0 objects on the other side. Mandatory means connects to minimum 1 on the other side, right? So you can just understand those as the maximum and minimum number of entities that each entity on one side connects to on the other side. Let's try to think about that as we look at the following example. So employee and department with the manages relationship, again, the same relationship that we've seen multiple times so far. Going from employee to department. The question that we're asking is how many departments can an employee manage, right? So an employee can manage 0 departments because they might not be a manager at all. But if they are a manager, they can manage only 1 department. So the minimum is 0, maximum is 1. So 0 tells us that this is a partial participation, and then the maximum 1 is the cardinality on that side. Now let's look on the opposite direction. From the department point of view, how many managers can a department have? How many people managing that department can there be? Minimum 1. It must have at least 1 person managing it, and it cannot have more than 1 person managing it. So it's just 1 manager. So the maximum and minimum are both 1. So minimum equals 1, this means total participation. Maximum equals 1, that means cardinality is 1. Another example to just illustrate the same kind of like method of thinking again. Employee works in department, not manages, works in. Now we have the same question from the employee direction. How many departments that the employee works in? Employee works in at least 1 department and at most 1 department. So employee only works in a single department. So this means that it's total participation because it's at least 1, and the cardinality over there is 1. Now on the department side, how many employees work in this department? You must have at least 1 employee, otherwise the department will be empty. You cannot have an empty department. And at most, you might have multiple employees working in that department. So 1 minimum means total participation, n maximum means cardinality is n. So this is both the cardinality and participation represented together. Let's talk about a different notation or a different way to represent relationships in ER diagrams. So this is called the crow's foot notation, and we'll see why very shortly. So suppose you have the 2 entities. Again, they're connected. There's some relationship here. And we're looking at it in the same way we just described, like in terms of minimum and maximum. So entity 1 can be connected to some number of objects from entity 2 side. This number can have a minimum, min 2, and maximum of max 2. And then the other direction, entity 2 is connected to some number of objects from entity 1 with minimum, min 1, and maximum, max 1. So we represent those on the diagram in this way. Starting from entity 1, you represent the minimum and maximum number of entity 2 objects in this way, and we'll see how they are represented. But just keep in mind that the maximum is usually closer to the entity and the minimum is like further from the entity. And then the other question is represented closer to entity 1. Again, the maximum is closer to the entity and the minimum is away from it. Now we need to know how do we represent these min and max values, right? Min can be 0 or 1, max can be 1 or many. So we need something to represent 0, something to represent 1, something to represent many. And this is how we represent them. 0 is represented as a circle, 1 is represented as a vertical line, and many is represented as this symbol that looks like a crow's foot, hence the name of the notation. So these are the 3 possibilities that we're dealing with. How do we put this on the line? Let's see that in an example. So we'll just take this part and put it in the corner here to refer to it. And now we have a relationship works in between employee and department, right? So let's look at the employee. Employee works in at least 1 department, at most 1 department. So minimum is 1. We're going to put a vertical line. Maximum is 1. We're going to put another vertical line. So the one closer to the department, that's the maximum. The one away from the department, that's the minimum. Going from the other side, department has minimum 1 employee, maximum n or many employees. So the minimum is 1, maximum is many, which is the crow's foot symbol. We're going to put it like that. So again, this illustrates the same information, but in a different way. Another example. Now we're looking at the orders and products example. Again, an order contains one to many, like one or more products, and a product can appear in 0 orders or many orders. So for the order side, the minimum is 1, the maximum is many. So again, the symbol. From the product side, the minimum is 0, that's the circle, and then the maximum is many. So again, this illustrates both the participation and the cardinality ratio. As I mentioned, there are several other ways to illustrate or to represent ER diagrams. I'm not going to get into that in the video, but feel free to look it up. If you look up for ER diagram notations, you're going to find at least 4 or 5 ways to represent this. This is basically what I wanted to talk about today. So let's summarize what we talked about. We talked about relationships, how they connect different entities in an entity relationship diagram. We talked about some of the properties of relationships, starting with the degree. Said that relationships can connect one entity to itself, or 2 entities, or 3 entities, potentially more. Then we talked about cardinality ratio and participation, which tells us about how many objects are connected to each other through that relationship. And we've seen how to represent that in the entity relationship diagram in different ways. If I missed something, or if there's something else that you would like me to discuss next, please let me know in the comments. If you have any question about this video, please put them in the comments as well. Otherwise, if you like this video, please hit the like button and share it with others. Please subscribe to the channel if you haven't done so already. This helps a lot, and it will help you get the information as soon as it's posted. And with that, thank you so much for watching, and I will see you in the next video.